I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
Welcome to STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
Welcome to STEM Talk, where we introduce you to fascinating people who passionately inhabit the scientific and technical frontiers of our society. Today, our colleague Tom Jones will interview Brother Guy Consolmagno.
Brother Guy, as he likes to be called, was a slam dunk, no-brainer, unanimous choice of the Double Secret Selection Committee. This august group votes to determine which guests are privileged to appear on STEM Talk.
So, Ken, tell me, how many votes were cast in this election?
Just one, but it was unanimous. It's a rather small and focused group.
So Brother Guy is in no particular order a Jesuit Brother, a scientist, an MIT graduate, a Peace Corp volunteer, a professor, a science fiction geek, and last but not least, the director of the Vatican Observatory.
The Vatican Observatory, originally in Rome, is now headquartered at Castel Gandolfo, right outside of Rome. It's actually the Pope's summer residence. A few years back, Nancy and I visited Brother Guy at Castel Gandolfo. He was generous with his time, and I can assure you, Castel Gandolfo is not a hardship duty station.
So it's obvious that religion is a central part of Brother Guy's life, but so is technology, rationalism, and science. In 2014, Brother Guy was awarded the Carl Sagan Medal from the American Astronomical Society for his unique perspective as both a scientist and a man of faith.
Additionally, Brother Guy is the author of 4 or 5 really amazing books, including his most recent book with the provocative title, Would You Baptize an Extraterrestrial? His previous book, God's Mechanics, was a fascinating study of the religious beliefs of scientists and engineers.
With no further delay, let's go directly to Tom Jones's interview with Brother Guy Consolmagno.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk.
So my first question, Brother Guy, is tell us about your current position with the Vatican and how do you spend your typical day?
There's no such thing as typical in my life, believe me. I am both a scientist. I work in the field of meteoritics and the connection between meteorites and asteroids. We also use the telescope here in Arizona, so I observe small bodies in the outer solar system. In addition, I'm the president of the foundation that raises money to keep the telescope going and to do a lot of education and public outreach work. So I'm also teaching an online high school class and working with high school teachers. I tell people that I have half my time in Tucson, half my time in Rome, and half my time on the road. We haven't quite worked out the haves yet, but we certainly have the have-nots. It's an astonishing life because whether I'm in Rome or Tucson, in some ways it's like being any other scientist, except that I'll also find time to have an hour of prayer. I'll also find time to have Mass with the community. And I'll also find the time to do all of these other different items, whether it's reading up on philosophy or theology, or, to be frank, reading up in science fiction, because I do a lot of outreach in the science fiction world and science fiction fandom as well. Typically in Rome, I'll be up by 6:30 or 7, work in my office there until 10 o'clock. Everything stops for coffee at 10 o'clock. It's the best time of day. We've got this industrial strength cappuccino machine and an Italian who knows how to make it work. And then work through until we have the big meal of the day at 1:30. Now, that means, because I'm in Rome, that I'm working at a time when all my colleagues in America are still asleep, and so I can get work done. I don't get emails all the time. I love the Italian policy of having naps in the afternoon. But then 5 o'clock, I'll be up, usually take a walk through the gardens. That's my hour of prayer. Get back to work around 6. We have a Mass with the community at 7:30, and I may be in my office until 9 or 10 because, of course, that's the working day back in America. So that's when I do answer all the emails. It's a full day, but it's almost like getting 2 days worth of work in. But it's exhilarating because it reminds me of all the different worlds I get to live in.
It does sound very exciting and exhilarating to be in that position and spend your time that way. How did you get interested in science in general and astronomy in particular? Take us back to your youth and how you got started.
Well, I'm a Sputnik kid. I started kindergarten the year that Sputnik was launched. And I was starting my senior year in high school when people landed on the moon. How could you not be crazy about astronomy and about science in general? Every little boy in those days was going to be a scientist. Sadly, it was boys, not girls. That was the 60s. And so I was caught up in all of that. But then I went to the Jesuit high school in Detroit. That's where I grew up. My dad had been a navigator in the Air Corps in World War II. And he'd been an Italian kid growing up in Boston, but fascinated by the stars. In those days, astronomy was the realm of people named Percival Lowell and good Yankee names. But by my generation, Italian kids could do this too. He encouraged the astronomy. He showed me the stars. He got me the H.A. Ray book, The Stars, that teaches you the constellations. But then the Jesuits caught me and reminded me that there's more than just astronomy. They taught me Latin and Greek and philosophy and theology and expanded my horizons that way. So that by the time it came to go to college, I didn't know what I wanted to do. I wanted to study everything. Fortunately, my best friend was going to MIT, and I discovered that MIT had weekend movies and pinball machines and the world's largest collection of science fiction. And I knew I had to go there. So I figured out how I could transfer in and saw this department, Earth and Planetary Science. I said, that's astronomy. When I was a kid, I liked that. So I signed up, discovered that it was the geology department. I had no idea I was transferring into geology. But they do study planets and other places where rocks can be formed besides the Earth. And then I discovered that there are rocks that fall onto the Earth. These rocks, these are meteorites. And that just captivated me. From then on, meteorites were where my heart was. I've never looked back.
Brother Guy, why does the Vatican have an observatory?
Why doesn't every religion have an observatory? What makes you think of the universe bigger than yourself, better than astronomy, better than just looking at the stars? It's actually a deeper question. Why does anybody have an observatory? Astronomy isn't going to make you rich. It hasn't made me rich. It's not going to make you powerful. It's not going to get you girls. That certainly didn't work for me. But astronomy is one of those things that reminds you, not only are there bigger things than what's for lunch, but that you're a person with an intellect who can puzzle about these things the way that the cleverest cat or dog wouldn't bother doing. Now, the Vatican itself has, and the Catholic Church has supported education going back to the universities of the Middle Ages. And in those days, understanding how the universe works is a way of understanding how the Creator works. That's still valid. But there was a particular political moment in the end of the 19th century, in the 1890s, when suddenly, for the first time, people were claiming that the church was anti-science. And this came out of the politics of trying to prevent Catholic immigrants from coming to America, of trying to have professional universities rather than church universities in Germany, the anti-clericalism that was prevalent in France at the time, and in Italy for that matter. All of these things conspired for people to look for a reason to dump on the church. The big thing the church was doing that was considered anti-science was it was speaking out against eugenics. And eugenics was the very fashionable science of the 19th century, which ended up in a place we all saw and realized, well, maybe in this case the church was right. Well, the Pope in 1891 founded a Vatican Observatory to show the world that the church actually supports science. It's interesting, the document that supported the observatory and founded it in 1891 was just a few months after his encyclical that was all about social justice, Rerum Novarum, and how the church is also supporting labor unions and the rights of the poor to organize and demand just recompense for their labor. Of course, even then, that pope was being criticized for talking about things outside his realm. How dare he talk about economics? Nothing is new in this world.
How would you describe the relationship between faith and science?
Not only are faith and science not in conflict, you can't do science without faith. And that, of course, partly means you have to trust the other people are doing their science fairly. You have to believe in a universe that makes sense. You also have to believe that the scientific enterprise itself is worth doing. You know, if you think that the world is evil, then studying the world isn't going to be something you're going to want to do. And there are some religions that think the world is evil. If you think the world is controlled by demons and nature gods and all the things the pagans talked about, well, you've got your answer for why is there lightning and, why do crops grow. It's only when you reject those gods that you can then ask the question, how does the universe work? And how can I understand how the universe works? It's not every religion that can support science. I had a sad experience a few years ago in South Carolina giving a talk at College of Charleston when a kid comes up and he says, I want to be a geologist. So I said, that's great. My background is geology. And he says, how do I tell my mom? And I suddenly realized he came from a culture that saw religion and science as enemies. If that's your culture, then you're not going to have your family say it's okay to be a scientist. You're going to be looking like you're rejecting everything you were brought up from. That's a shame. Because, in fact, if you look at our history, science was founded by religious people. Science was done by clergy people back in the 17th and 18th centuries who had the free time to go out and gather leaves and sort things out and look for double stars and all the other worthless and wonderful things that science does, except noblemen and clergymen.
Brother Guy, if you would, describe for us the church's attitude today towards Galileo.
I'll say this about Galileo. Everybody thinks that's when the church turned against science. That's a 19th century myth. That goes along with everybody thinks Christopher Columbus proved the world was round. And you go, wait a minute. They knew the world was round. And for that matter, he didn't make it around the world. How did he prove anything? What you forget is Galileo was a good Catholic. He wouldn't be the first good Catholic to get in trouble with the church. But the church has made it up with him. And the church allowed him to go back to his villa and continue doing his science. His best book was written after that terrible trial. He could have fled to the Protestant North. He didn't. He was himself a very devout Catholic. His two daughters were both nuns. And he was someone who wanted the church to be on the right side of science.
So how do you view the relationship between the great expansion of scientific knowledge about the universe and the religious view of our society or our civilization's place in the universe? How does the view of humanity fitting into the universe sync up with science, or is it opposed by science?
Well, there's one great misconception that everybody has about the medieval view of the universe. They all say that, the Earth was the center of the universe in those days. No, it wasn't. It was the bottom of the universe. If you think of it, what was underneath the Earth, the inferno, hell, which is even closer to the center if you're going to make the Earth the center of the universe, nobody thought that hell was the center of the universe. Nobody thought the inferno was, everything that the world revolved around. Rather, the Earth was the bottom of the chain of creation. And what the Copernican revolution did was to say that all of the universe that we can see is operating under the same physics as the Earth, and we're all down here at the bottom, if it will. In fact, when the first book of Genesis was written, the people writing that were taking the best science of the day, Babylonian science, but saying, rather than the Babylonian myths who say the point of the universe is to glorify Babylon, the point of the 7 days of creation is to lead you to the Sabbath and to lead you to God. And bigger than the flat Earth separated with the dome above and waters below, bigger than that is the God who was already there at the beginning, who made it. 100 years later, the Greeks came up with the idea of a round Earth surrounded by spheres. That didn't cause any Galileo crisis. They just said, bigger than that is the God who created it. Ptolemy comes up with epicycles. Bigger than that is the God who created it. Even in the Copernican view, and then in the 17th and 18th century, the idea that we are one star among a galaxy of stars, bigger than that is the God who made it. The universe that we live in now, where we can only see 13.8 billion light years, But with inflation, probably there's 150 billion light years that came out of the Big Bang that once was touching us, and who knows what other multiverses are beyond it. Bigger than that is the God who created it. What science has done is to remind us forcibly over and over again how big, how incredible the creator of the universe must be. So science can only enrich our view of God.
So, Brother Guy, you once wrote that nothing within the universe can exist to explain the fact that it exists. Can you unravel that thought for us?
Well, that's hardly a new idea. You can find, in the 20th century, Wittgenstein points out that no thing can have its own meaning within itself. A telephone only matters because there's somebody using the telephone. A bar of chocolate is hopeless until you unwrap it and eat it. You've got to have something outside of the thing to give the thing its meaning. If the universe has a meaning, we can't prove it. If I postulate there's a reason why I'm here, that meaning has to be outside of the universe. Therefore, it can't be part of nature. It's got to be supernatural. And frankly, this is not a new idea. Without that, the universe is meaningless. The former chief rabbi of England, Jonathan Sacks, wrote a wonderful book recently where he retranslates a classic bit of Hebrew scripture that usually starts vanity of vanities, all is vanity. He says, really what the philosopher is saying there is meaningless, meaningless. Everything is meaningless. We all come to the same life. We all come to the same death. No, there's nothing new under the sun. And this cry of despair is the cry of someone who has not recognized the existence of a God outside of the universe. So these thoughts go back thousands of years. And like all good philosophical thoughts, they're not questions that you can come up to an answer and say, solve that one, go on to the next problem. They're wonderful thoughts that the longer you think of them and the more you live and have more experience to apply to them, the more you understand where they're really coming from and what they're really getting at.
I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
So, Brother Guy, you were telling us you went to MIT and you were pursuing a science education there. So tell us about how you became a professional scientist and when and in what order did you then wind up becoming a brother?
I had thought, that time when I was deciding should I transfer into MIT or not, the other option would have been to join the Jesuits. And I talked to a Jesuit about that, and he said, well, son, have you prayed about this? I'm thinking, I'm 18 years old. Who prays? Give me a break. But I think, okay, it comes with the territory. And at that point, I, followed his advice, went to my room, closed the door, sort of looked at the ceiling, waiting for a voice from the ceiling to come tell me what to do, and there wasn't one. And while I was waiting for that voice, I, thought, what does a priest do for a living? Priest talks to people, deals with people with problems, listens to them. Whenever the guys in my dorm would come to me with their problems, all I could think of is, life is tough when you're stupid. Why are you telling me these things? I was not a person who dealt with people. I was not a people person, which made me suddenly realize being a priest was totally the wrong job for me. And then I thought, either there's no God and he hasn't told me anything and that'd be dumb to be a priest, or there is a God, and he's just told me it would be dumb for me to be a priest. Either way, the answer was stop doing this, wondering about priesthood, go be a nerd, go to nerd school. And I did that very happily for 20 years. But by the time I was in my 30s, I had gotten my doctorate from Arizona. I had had a postdoc at Harvard. I had another postdoc at MIT. 2 postdocs means you can't get a job. I was lying in bed wondering, why am I doing astronomy when people are starving in the world? It goes back to the first question. Why does the Vatican do astronomy? Why does anybody do astronomy? I didn't have an answer. I thought, There are so many things that the world needs. One more paper on the moons of Jupiter isn't going to matter. So I quit, and I joined the Peace Corps. I told the Peace Corps people, I'd go wherever you want me to go, do whatever you want me to do. And they said, sure. So they sent me to Kenya, and within 3 months, I was at the University of Nairobi teaching astronomy to graduate students. But I was also going up country where all my other Peace Corps friends were, and setting up a little telescope, and everybody in the village would come and look at the moon and look at Saturn and look at Jupiter. Have you ever seen the rings of Saturn through a telescope? Now, have you ever seen the rings of Saturn and not gone, wow? Everybody goes, wow. This is what it means to be human. Suddenly it hit me, that's why you do astronomy. To be able to share with people that thrill of seeing the universe outside yourself, to remind them that we're all part of the human race that went to the moon and had this incredible adventure of learning who we are and what the universe is. That's why we do astronomy. I came back and I was teaching at a little college in Pennsylvania, Lafayette College, and loving every minute of it. And I thought, why don't I do this as a Jesuit teaching at a Jesuit school? Then I can really concentrate on, the things that I'm interested in. Besides, I was getting older. I realized I was not going to meet, the perfect woman who would put up with my craziness. So move on to plan B. I joined the Jesuits, discovered that plan B was really plan A, that they were waiting for me, not as a priest. I'm still not that great listening to people's problems. I still think, you're an idiot. But as a brother, someone who can work with the priests, do the work that I am good at. The Jesuits were able to use all of the talents that I have. But you take these 3 vows. Poverty, I was used to that. I'd been a grad student. Chastity, I was used to that. I'd been a grad student. Obedience, not used to that one. And after 4 years in the Jesuits, I get a letter out of the blue ordering me to go to Rome, eat that terrible food, look at that boring scenery, live in a palace with the Pope, and oh yeah, there are 1,000 meteorites waiting for you to do whatever research you want to do with them. I had to obey. Life is tough, but there it is. And it really, I joke, but in fact, it was a disappointment that I didn't get to teach. But the thrill of doing astronomy without having to worry about the politics of getting grant money, without having to worry about tenure and will my research have a result before I'm up for a review, I was able to start projects that took 10, 15 years to come to fruition, measuring the physical properties of meteorites, looking at the color patterns of trans-Neptunian objects. I was able to do science that my fellow scientists couldn't do because I had a far more stable funding situation. And as a result, I've been able to contribute something to my field. Won't make me famous, but I think it's a really solid contribution that everybody gets to use.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research lab pioneering groundbreaking technologies aimed at leveraging and extending human cognition, perception, locomotion, and resilience.
So you headed up the Vatican Meteorite collection. And what do you think that meteorites tell us about the birth of the solar system? What fascinated you about them to begin with? And why do you think they're so important to study today?
Well, I mentioned I was a baby boom kid. And so in the big building boom after World War II, lots of subdivisions. I lived in one of them. And as you saw the houses being built, you'd see the scrap pile in the backyard. And the scrap pile might have, you got green tile in this house. Oh, you've got the oak paneling in this house. The asteroid belt is the scrap heap of the solar system. By looking at the meteorites, we're seeing the bits and pieces that didn't get into a planet. And it tells us what the ingredients of the planets are. It tells us what materials are in the core of a planet that otherwise we'd never be able to see. So the first thing is chemically, they tell us what the solar system is made out of. But then when you look at them physically, it also is a record of what was going on 4.5 billion years ago when the planets are being formed. We can see that planets and stars are formed from clouds of gas and dust. Gas and dust, great. So how come the meteorites aren't just big dust bunnies? Why are they actually lithified into real solid rocks? That tells you something about the physical processes going on when the planets are being formed. So they're the pieces of evidence. They're the scraps. They're the bits that allow the theorists, the detectives, to work backwards to figure out what really happened, who done it, back when the solar system was formed.
Now, in that period when you were working at the Vatican with the Meteorite collection, which goes back a couple of centuries, I think you did get to meet, was it Pope Benedict who came to visit and describe his reaction and interest in meteorites and in astronomy in general?
Well, I've managed to meet all three popes. Pope John Paul II would have us over for Mass on the feast day of the Jesuits, the Feast of St. Ignatius. And then when we moved to our new lab in the Papal Gardens, Pope Benedict came to dedicate it. And he was fascinated by the meteorite collection. I held up one of our large pieces of Nakhla, which is a meteorite we think comes from Mars. And naturally, he wants to know, why do you think it's from Mars? So we were able to explain the isotopes and the gases, and the fact that the age is about a billion years. There are some meteorites, some shergottites that are, maybe only a few million years older. So the ages certainly are much younger than the ages of other meteorites. Still, a billion years is a long time. And he looked and said, yeah, plus or minus 100,000, I'm sure. Pope Benedict, one-on-one, is a very sharp guy. Cracked a couple of jokes about the collection, listened carefully as we were explaining it. The explanation started in Italian, switched to English as I got more technical and realized my Italian couldn't handle it. His English is great. And it was just a fascinating time because he was delighted to hear about these things. In fact, in a number of his homilies later, he made reference to astronomy in ways that taught me things about our own history. He was the one who pointed out that Pope Sylvester II, the Pope in the year 1000, was himself an astronomer. He was the guy who brought armillary spheres from the Arab world, and Arabic numbers for that matter. He was the one who made a wonderful observation at the Easter homily in 2012, saying that the way that our modern civilization sort of isolates us from each other, isolates us from the presence of God, is the way that light pollution blinds us from being able to see the stars from our cities at night. How many other popes can you think of who would talk about light pollution? Yet that's one of the really important things that I think has alienated too many people from the physical universe. That, my friends at MIT would joke about going out into that horrible big room with the blue ceiling because they'd much rather be in front of their computers nerding away. Well, they said it as a joke because they realized it was a joke. But there are too many people who don't get out and look up from their screens and see the universe the way it is.
How about Pope Francis? Have you had a chance to introduce the topic of astronomy or meteorite research to him?
I couldn't introduce it to him because he already knew about it. The director of the observatory, Father Jose Funes, is also from Argentina. We joke he's the second smartest Argentinian in Rome. And when Jose was first looking to join the observatory, finishing up a master's in astronomy, he was interviewed by then Father Bergoglio. So they know each other going back to when Jose first entered the Jesuits. Father Bergoglio, now Pope Francis, came and had lunch with us his first summer as Pope. I again gave him a tour of the place. I showed him a meteorite that had fallen in Buenos Aires, and he was thrilled to see that. But you remember, he's also himself got a degree in chemistry and understands science and understands, more importantly, why the abstract work that we do actually has an importance to human beings, and why the fact that we can introduce our work through our summer schools to students from the third world, from Argentina and Chile and Kazakhstan and Malaysia and every country in the world, is an important way that we can share the intellectual knowledge of the human race in places that otherwise might not be able to get it.
Now you have this beautiful book, The Heavens Proclaim. Here, I've got it in my hand, and there are some lovely shots of the meteorite collection here inside the book and some of the meetings with the popes as you engage them on this subject. So we have these meteorites, these samples of asteroids in our hands today. Why do we need to go out and study the asteroids firsthand with spacecraft or do more research from ground-based observatories? Don't we all have the answers right here?
Oh, yeah. Sure we do. 35 years ago, when I was a student at Arizona, we used the meteorites that we knew came from Vesta, these basaltic meteorites, and did chemical tests and chemical models that are pretty standard models to show what the interior of the body that made them must be like. And we were able to show conclusively that they're 10 times richer in trace elements than typical meteorites, so they must represent 1/10 of the body that they were made in. Then we sent a spacecraft to Vesta. The Dawn spacecraft orbited the last couple of years. Now it's, of course, orbiting Ceres. While it was at Vesta, it made some measurements that showed the core of Vesta is twice the radius of what we had said it should be. The crust of Vesta was at least 6 to 8 times thicker than what we said it ought to be. And suddenly we realized Vesta was not this pristine body that melted and left a little basaltic crust that chipped off and made the meteorites. In fact, it's looking now like Vesta is a second-generation body. It's something that maybe was a lot bigger, got ripped apart and put back together. And it's telling us of an episode in the early solar system that we hadn't thought about before. The episode when Jupiter was just forming and really stirring up all the material that's in the asteroid belt now, stirring it into massive collisions that might not even be head-on collisions, but hit-and-run collisions where things get ripped apart and put back together. A theorist had proposed this a few years ago. Now we've got the evidence of comparing the meteorites against the body we know the meteorites come from. And now we have a much deeper understanding of what was going on. The crazy thing about scientific knowledge in general is that every time you answer a question, you ask 5 more. Knowledge is like an island. The more you know, the bigger the island. But the bigger the island, the longer that shoreline that separates what you know from what you don't know. The more you realize you don't know. That's why we'll never run out of things to look for, and why science is not about finding answers, but understanding the things we do know in a deeper and more profound way all the time.
That same meteorite collection has dozens of different kinds of rocks that we don't link specifically with known asteroids. And so it seems to me that, we've got this vast untapped collection of parent asteroids out there whose connections with our meteorite collection is very fuzzy. And to me, that's one of the most exciting things about venturing into the asteroid belt or to the near-Earth asteroids, to find out what those connections are and what they mean about the birth of the Earth and the Moon system.
Exactly. And of course, the spectra will tell you that this meteorite is consistent with an asteroid like that asteroid. But except for Vesta, it's been hard to try to make it a direct one-to-one connection. Furthermore, as we learned with Vesta, when we get samples of other asteroids, you're going to discover that everything we thought was true, was true, but it's more complicated than you thought. And you have to go out there and find it to really figure out how it's more complicated than you thought, because it's the surprises where the real excitement takes place. Meanwhile, we know that the asteroids that are coming close to Earth, the near-Earth asteroids, aren't all that different from the meteorites. Meteorites are 10 to 15% metal. We know what's in the metal. You could mine that metal and, supply the Earth with all of the rare elements, all of the platinum and gold, heck, all the iron and nickel that it needs. What's that going to do to the economy of the Earth? What's that going to do to the way we're polluting the Earth? It's going to change things. It's going to disrupt things, and it's going to happen. Maybe not in my lifetime, though people are already starting companies to look at that kind of exploitation. But it will happen, and it will happen because of the work we're doing now.
Brother Guy and I both studied under the same professor, John Lewis, who was at MIT in Arizona. He was very interested in space resources. And I actually have a question. What are the practical possibilities for using these resources from asteroids to advance specifically human space exploration, for example?
Well, obviously, they're, as you say, John Lewis at MIT and then Arizona worked out a lot of the details of how it could happen. And Tom Jones, one of his students, is one of the people who's really involved in trying to set up a company that can make it happen. Tom's a former astronaut. We don't know. We don't know what the challenges are going to be. We don't know where the real payoff is going to be. You can make guesses, but it's not until we do it that we'll find out. When I was at MIT in the 80s, in a postdoc, I had a chance to work in a software company, leave science behind. There was a guy in my dorm who had invented this program called the spreadsheet program. It was VisiCalc. You don't remember VisiCalc?
Mm-hmm,
Yeah. You don't even remember the company that replaced VisiCalc, which was Lotus 123. We're probably not going to remember the first companies that exploit space. We're going to learn from their mistakes, and I hope we honor the people who are brave enough to make the mistakes. I don't know where it's all going to go. I know it's going to happen, and I know it's going to be a lot of fun.
STEM Talk is an educational service of the Florida Institute for Human and Machine Cognition, a not-for-profit research lab pioneering groundbreaking technologies aimed at leveraging and extending human cognition, perception, locomotion, and resilience.
One thing that we all agree is you've got to have an inventory of what actually is out there. Knowing ahead of time is the key to saving the Earth if something big is going to come and hit us. Because the bigger it is, the longer it is going to take to deflect it, to move it out of the way, or to prepare ourselves. That still isn't going to solve us the problem of a comet coming in, because generally you only have about 3 or 4 years advance warning for a comet. But even there, doing an inventory of what's out there, having the 3 or 4 years warning is better than no warning at all. And so the absolute first step is to continue funding the efforts of figuring out what's out there, and the lab efforts like we're doing of what are they made out of? What would it take to take them apart, move them around? Beyond that, I think simply having an international group who are willing to talk about it and willing to talk about the protocol of what do we do if, to get us all thinking about it at the same time, if nothing else, it can't hurt, and it might get us into the habit of talking to each other, which is always a good thing. It's got to be an international operation. Solving the problem by diverting it so it doesn't hit my country and hits your country is not a real answer. Because something that was big enough to destroy the dinosaurs didn't care what species of dinosaur it was. They all went.
What do you think is going to happen when and if we discover life on another planet?
Do you want to know my real answer? The cynic answer in me? Well, worse than that. It's going to be a 3-day wonder. Everybody will be excited, and then they'll worry about the latest scandal of the latest pop star, and we'll just go back to our ordinary lives. In a sense, that's because I think most people already recognize that they're probably there. It's not going to be such a shock to the system that people seem to think it's going to be. Just as finding planets around other stars has been incredibly exciting to us in the astronomy business, and most of the rest of the world go, oh yeah, of course, I read science fiction. Naturally, there's planets around other stars. And they're right, and naturally there's going to be life on other planets. But to the scientists, it'll be really exciting because the question isn't, is there life, but what's that life like? The question wasn't, are there planets, but what are those solar systems like? And only as you study them and classify them and sort them out and try to find similarities and differences among them and from what we have here in our own solar system, only then do you do the real science. And that's the task of tens of hundreds of years. The same will be true of finding life elsewhere. It'll be exciting, it'll be fun, but it will be really exciting and really fun to the biologists who finally have a way of saying, this is life, that isn't life. We've got more than one example. We can see what's common and what's not uncommon. Are
you confident that we're going to find life in this solar system? What are the odds of that, do you think?
I'd give it 50-50. Back when I wrote my master's thesis under John Lewis at MIT, I ended it by saying in the icy moons, which I had done computer models of, really crude computer models, I said there's going to be water. The water is going to be in contact with organic materials, but I'm not going to predict life. I'll let somebody else predict that. I was being very, very cute. So I'm the first person to not predict life in the oceans of Europa. But it's something we were thinking about, in 1975. And nothing that we've learned about Europa has made it any less likely. We've confirmed that there are oceans there. We've confirmed that there are oceans in the ice crest of Enceladus. We've confirmed that there are liquid hydrocarbon lakes on the surface of Titan. Nothing we've learned has ruled out the possibility of life. But the hard part is finding it and proving that it's life and getting it back here so we can study it.
I don't always listen to podcasts, but when I do, I listen to STEM Talk, interviewing the most interesting people in the world of science and technology. Stay curious, my friends.
If there are planets that can support life, if there is life on those planets, if that life can be intelligent, if that life can ask questions about a being beyond itself and choose to want to love or not love that being, intellect and free will, we call it. If those creatures can communicate to us without us having to wait 20 years for an answer to get back and forth, if we can figure out what they're saying, well, how many ifs have I just said? I think I've run out of fingers. If any one of those ifs is not true, we'll never know. But there's no reason why all of those ifs couldn't be true. And in that case, I think we'll find that they're asking the same questions we're asking. And as is the case with us, these aren't questions that have a pat answer in the back of the book, but questions that asking and sharing will make the questions richer and deeper for everybody. So meanwhile, I'm in England. It's 2012. Some British journalist, who of course is the cream of journalism, comes up and is trying to get me to say ridiculous things about the church, which I'm not in any mood to say. Finally says, all right, would you baptize an extraterrestrial? And I go back, yeah, sure, if she asks. Well, I realized later the question was supposed to be a trap question. The question was supposed to be that if I said yes, I'm making myself out to be arrogant to think that I have something to teach these extraterrestrials. And if I say no, I'm admitting that Christianity is just for us stupid yokels here on Earth. But by making baptism the extraterrestrial's choice, I'm completely destroying his frame of the question and pointing out that, first of all, just because you can travel across great leaps of space doesn't mean you're ethically more advanced. You know, the Nazis had a lot better technology than the ancient Greeks, but that didn't make them ethically more advanced than Socrates. In the same way, asking the question is what's important, not thinking you've got a pat answer.
So, Brother Guy, if God is bigger than the whole universe, and if he doesn't even sweat the small stuff, what should we pray to him about? And can you tell us what you pray to God about?
It's a wonderful question because it makes you recognize what the meaning of prayer is. The best example, really, I think, are a couple in love. And I forget where I read this. Maybe it was a trashy movie someplace where a young couple in love are seeing some old couple who are just sitting side by side, not talking. And they say, yeah, that's what happens when you're married too long. You run out of things to talk about. No, sometimes that's what happens when you're married so long that just being in the other person's presence is a phenomenal act of love, and you can shut up and listen. A lot of prayer is just shutting up and listening, turning off your brain, turning off your concerns, remembering the universe that you're in, and feeling the presence of the love that's in the universe. Other times, prayer is asking, what am I supposed to be doing here? And then shutting up and listening as you feel a call from outside that says, oh yeah, time to be a brother now. You go, brother? I thought the priest said all the time, no, brother. That call that I still don't understand when I was happily a professor at Lafayette College and suddenly had this urge to do something more. Sometimes it is a matter of presenting your needs. There's a reason why you talk to a shrink rather than working these things out for yourself. It's only when you express the need, when you write it down, that you realize what it is you really need, that you realize what it is that you're really looking for. And sometimes God does arrange, for lack of a better term, divine coincidences. A miracle, which is not some violation of the laws of nature. There's no violation of the law of nature in seeing a beautiful sunset. but there is a miracle in seeing the sunset just when you needed to see it, just when you needed to be reassured that there was beauty in this universe. Sometimes in the asking, you wind up recognizing the answer that's been sitting there all along.
You're listening to STEM Talk, and we're interviewing Brother Guy Consolmagno. You can find out more information on some of the things he is talking about in today's interview by going to youtube.com/theihmc and viewing either of his evening lectures entitled God's Mechanics, The Religious Life of Techies, and Discarded Worlds, Astronomical Ideas That Were Almost Correct.
Now, Brother Guy, you've explained how you think science and faith complement each other, but you've probably run into people who disagree with you on that. Have you had any run-ins with people at your lectures who are very skeptical of your point of view?
Fewer than you'd think. One of the things when I became a scientist, I expected to run into a lot of skeptics. And sure enough, when people found out that I was a Jesuit, they came up and go, you go to church? Like, as they're implying, sure couldn't tell. And then they'd say, let me tell you about the church I go to. And I'm thinking, you go to church too? There's two of us? I've known you for 20 years. I never knew you were a churchgoer. A lot of us go to church. A lot of us have these questions even if we don't go to church. I find most of the people who are hostile to religion, quite frankly, are elderly white males. And I intend to be an elderly white male someday, so I'm not, dissing them. But it's a generational thing. Younger people are much more open to different ideas, different religions than theirs. So many of my friends who don't claim to go to church nonetheless thought this Jesuit thing was a really cool thing to do. What's more, I'm reminded that, the first commandment that you're supposed to love God also says you put false gods aside. Most of the gods that are out there these days are false gods. Most of the people who claim to be atheists don't believe in a God that I don't believe in either. And I'm delighted that people reject a lot of the false gods out there. The mean God, the God that wants to punish you if you do exactly the wrong thing. The God who has the entire world on strings and doesn't allow anything, any kind of freedom to evolve and take advantage of the wonderful laws of science that God gave it. There are a lot of false gods out there that are worth rejecting. The hardest are actually the people who think believing in God means rejecting the evidence of reason, the evidence of their own eyes. That, if you're a creationist, you want to believe in Jesus Christ, but you also want to believe in the 7 days of creation. Tell me, which is more important? Because Jesus never talks about the 7 days of creation, never talks about believing in things literally. He talked in parables. He was happy to tell stories to get a point across. And I'm sure he would tear his hair out as, people are wondering, well, what kind of medicine did the Good Samaritan use when he was helping out the guy? And, what brand of shoes does he wear as he's walking down the street? Those are not the questions that Jesus wants us to address. But you find even among people who you might think would be creationists, you might think would be fundamentalists, when I've encountered them, again, I'm surprised and delighted to see that really what they're afraid of are the scientists who want to use science to try to pry them away from their belief in God, as if being a scientist meant you had to be an atheist. Anybody who says that sure doesn't know their history as science, and frankly, doesn't really understand what religion is all about. Unfortunately, the scientists you find on TV most often are the ones who are trying to sell you something, and they're trying to sell their own bona fides by saying, look at me, I'm waving the atheist flag. Anybody who's got to do that doesn't have any confidence in their own science. They don't believe in themselves as scientists. Any more that someone who says that science threatens their faith, you have to say they don't have much faith if that's what's going to threaten it.
So what would be your advice for someone who has a strong faith, they believe strongly in their God, but they still want to pursue a scientific career?
Well, I've met very, very strange people who can somehow at the same time hold a desire to do science with a faith that the Los Angeles Lakers are a great basketball team, when all right-thinking people know, of course, it's actually the Boston Celtics. What difference does it make? The question to ask is, where is your desire? And where is your desire leading you? And not to be misled. You know, I have a desire for a chocolate sundae, but if I did nothing but eat chocolate sundaes, number one, I'd make myself sick. And number two, after a while, I'd be sick of chocolate sundaes. Not every desire is a desire from God. But when you know where your deepest desire is, to know truth, to know beauty, to recognize the beauty in nature that you get from doing the science right, and to see that is, that looking for the elegance of the universe is not only a pointer to scientific truth, but ultimately a pointer to God, you can't lose.
Okay, Brother Guy, is there anything else you'd like to add?
There's a couple of wonderful things about hitting 60 and being a scientist in your 60s, as I am now. It relaxes a lot of the fears that I think drive younger scientists. I'm not worried anymore, am I going to have a job? It's rather, what am I going to do if I ever get to retire? I'm not worried about what do people think of me, because what they think of me is set in stone. There's a friend of mine, married a high school friend of mine who died, and so as a widow, she's gone back to graduate school. And she says being a graduate student in your 60s is great, because you're only motivated by the desire to find out what's true, rather than playing the politics, rather than worrying about what your advisor thinks of you. In a bigger sense, what we do at the Vatican Observatory is to remind all the people we collaborate with, my collaborators in Florida and in England and in northern Arizona, about why we do this stuff. That it's not about showing up the other guys. It's not about getting the big grants. It's not about having stuff named for you. It's about the love of truth and just the thrill of seeing how the universe fits together and how the pieces work. If you can remind people of that, then that's the greatest preaching I can do. Because at the end of the day, we're all looking for truth. We're all looking for beauty. We're all looking for love. Those are the traits of the God I worship. Those are the traits of what I find in my religion when it works right, and what I find in my science when it works right. And when it works wrong, it gives me a little sense of tolerance to give it slack. I remind people that as a planetary scientist working at the Vatican for the last 20-odd years, I've had to deal daily with a huge, stupid bureaucracy run by people who can seem like they're idiots, who more often than not get in my way rather than letting me do the things I want to do. But I put up with it because NASA is the only outfit that got us to the moon. And all of the faults that I see in the NASA administrators are just the faults in myself, written large. And they're the mistakes that I would make if I were in their positions. We're all human beings stumbling towards the truth. But with a large organization, whether it be a church or a university or a national or international astronomical institution, it's only together that we can do these things. I can't get to the moon on my own. I couldn't find Jesus on my own. I can't develop a spirituality that can top what's already been worked out for the last 2,000 years any more than I could reinvent Newton's laws on my own. But it's as a community that we share these things, that we develop these things, that we learn from each other, that we point out to each other the insights that we had without even realizing it. How often have I had a conversation in science where I go, you realize what you've just said? You've said that meteorites are really like, and they go, oh, you're right. I just kind of assumed that all along. You realize, no. We never assumed that before until you pointed it out. Sometimes the greatest advances occur when we don't even notice, and we need somebody next to us to point it out. Science is not a book of facts. Religion is not a book of rules. It's a conversation in a community. And that's why we have to treat each other well within the community, why we have to seek out the community, why we go to scientific meetings, and why at the end of the day, it's based not only on mathematics and observation, but also on friendship and love.
Okay, Brother Guy, I know that we can find your books, The Heavens Proclaim and Would You Baptize an Extraterrestrial? And your lecture is at the IHMC website. But can we meet you in person? Are you out there on the lecture circuit, or are you too busy with your Vatican Observatory work to let us see you in person?
I'm not only on the lecture circuit, but I am running a blog with a couple of other wonderful people. It's called The Catholic Astronomer, and it's just www.vo foundation, all one word, vofoundation.org/blog. And on that blog, you can see things I've written, things some of my friends have written on this whole topic of what's new in astronomy and how does it relate to us as people. And on there, you can also find the calendar, where I'm appearing, what I'm doing, where I'm going, and other people who are affiliated with the blog. It's a lot of fun, and we'd like to get more people to come and take a look at it. The Catholic Astronomer.
Terrific. I had one more question. Is it possible to go to any of the Vatican Observatory facilities? Are they open to the public in any way?
The observatory that we have in Tucson is just a set of offices, very boring. But the telescope that we have on Mount Graham can be visited through an outfit called Discovery Park. That's the Science Museum in Safford, Arizona. And you can find them by Googling Discovery Park. They have tours on Saturdays to go up and see our telescope and the 10-meter microwave submillimeter telescope, and the largest single piece of glass telescope in the world, the LBT, Large Binocular Telescope. Those are exciting places to see. So you do that through the Discovery Park people. In Rome, we're out in the Pope's summer gardens. Well, under Pope Francis, we're developing ways for those gardens to be open to the public. You can already see the gardens now. You can get a tour. We are working on putting together a visitor center there. It's going to be a couple of years before it's open, but we hope to be able to show something about our history and the current work we're doing in astronomy.
Excellent. Well, I've really enjoyed the conversation. We'd like to thank you for being with us, and I hope that we'll have a chance to talk again soon, face to face.
Best of luck editing it up. Have fun.
STEM Talk.
STEM Talk.
STEM Talk.
STEM Talk. STEM Talk.
Wow, what a fascinating interview with a very eclectic and very interesting individual.
Agreed. Tom did a wonderful job on the interview, and Tom and Brother Guy sharing the same educational experience with the same PhD advisor made it even more interesting for me. Brother Guy exemplifies the ability to clearly communicate complicated subjects at the boundary space between faith and science, and he sees no obstacle to have them combined in a single person. Very compelling individual.
Absolutely. And we're very lucky to have him here on today's interview. Brother Guy has actually given 2 wonderful lectures at IHMC in the past, and these are both available on our website, ihmc.us, and on YouTube. This is Dawn Cornegas, host of STEM Talk.
And Ken Ford.
Signing off for now.
Goodbye.
Thank you for listening to STEM Talk. We want this podcast to be discovered by others, so please take a minute to go to iTunes to rate the podcast and perhaps even write a review. More information about this and other episodes can be found at our website, stemtalk.us. There, you can also find more information about the guests we interview.